Here we have a SAT math question. Okay, let's go with the information. If ax positive 2 times bx positive 3 equals to 14x square positive cx positive 6 for all values of x and a positive b equals to 9, what are the two possible values of c? Okay, here we have an equation. Okay, now let me take this equation as it is. It is ax positive 2 times bx positive 3 equals to 14x square positive cx positive 6. Okay, on the left side, we have a product of two binomials. I'm going to use a FOIL method to multiply these two binomials. So that is, I'm going to multiply the first terms over here. Ax times bx is abx square. Now I'm going to multiply the outer terms ax and positive 3. Then I'm getting positive 3ax. Now I'm going to multiply the inner terms. That is positive 2 times positive bx will become positive 2bx. Now I multiply the last terms, positive 2 and positive 3. I'm getting positive 6 equals to 14x square positive cx positive 6. Okay, now we can write the first term ab times x square as it is. Okay, when you look at the second term and third term over here, both of them have the greatest common divisor x. So x can be factored out. So if x is factored out, then I'm getting 3a positive 2b times x. So here x is factored out from these two terms. Then we have positive 6 equals to 14x square positive cx positive 6. Okay, here in this equation, two expressions are equal. So whenever two expressions are equal, the coefficients of like terms must be equal. So the coefficient of x square on the left side over here is ab. The coefficient of x square on the right side is 14. So ab must be equal to 14. Okay, and the coefficient of x on the right side is c. The coefficient of x on the left side is 3a positive 2b. Okay, now we have to consider the given information, that is a positive b equals to 9. So let me write that over here. Okay, now we have tried the possible values for a and b, so that the product of a and b equals to 14 and the sum of a and b equals to 9. So let me write the stuff over here. Here we have a and b. So if I take a equals to 2 and b equals to 7, and if I take a equals to 7, b equals to 2. So I'm getting two pairs of values which meet these two conditions. So because when I take the first pair 2 and 7, when I multiply 2 and 7, that is equal to 14. When I add 2 and 7, that is equal to 9. So now let's consider second pair. When I multiply 7 and 2, that is 14. And when I add 7 and 2, that is equal to 9. So we get two different pairs of values for a and b. So that ab equals to 14 and a positive b equals to 9. Now let's consider the first pair of values for a and b and find the value of c. Okay, now let me do this separately. Now I'm taking a equals to 2 and b equals to 7. Then we get c equals to 3 times 2 positive 2 times 7. Then we get c equals to 3 times 2 is 6 and 2 times 7 is 14. Then we get c equals to 20. So when a equals to 2 and b equals to 7, I'm getting one of the values for c, that is 20. Now let me take the second pair of values, that is a equals to 7 and b equals to 2. Then I'm getting c equals to, so I have to plug in a equals to 7 and b equals to 2 over here. Then I'm getting 3 times 7 positive 2 times the value of b is 2. Then we get c equals to 3 times 7 is 21, 2 times 2 is 4. Then I'm getting c equals to 25. So now I got the second value of c. So now from the given information, the two possible values of c are 20 and 25. We find 20 and 25 in answer choice D. So the correct answer choice for this question is option D.